We've returned here to the Hampton in JFK, room 1215, and we are on the amazing application of our 5x12 matrix. And previously we have calculated delta. We have calculated the numerator value for Ni1, the numerator value for Ni2, and the numerator value for Ni3. Correspondingly, we have calculated I3 to be equal to 10800 over 1368 to be equal to 78.9473 in the positive, which implies that our assumed current I3 is moving in the right direction. Alternatively, we have calculated I1 to be equal to minus 163 point something, and it's in the negative, so this implies that now the assumed direction is now reversed and is in the anticlockwise direction. Ni2 was equal to minus 27360 from our determinant, and therefore I2 was equal to minus 27360 over 1368 to be equal to minus 20 amps. So I2 likewise was in the reverse direction. So we'll move on now to calculate I4. And so we say I4 is equal now to N I4 over delta, which is equal to 1368 by calculation. And for Ni4, we will replace now the fourth column in the delta matrix via the voltage, the voltage values. So let's do that. Let's get back our delta matrix. Delta is equal to get back our delta matrix here. 12 minus 2, 0 and 0, minus 2, 6, 0 and 0, 0 and 0, 5 and minus 4. So now we place now, let's write about the delta matrix. And 0, 0 minus 4, 7. And so we say now that N, I4, will be now equal to the determinant now of 12 minus 2, 0, 0, minus 2, 6, 0, 0, 0, 0, 5, and minus 4. I'll replace it now by the voltage value. So we found V1 was equal now to what? Minus this and that, minus 240. And V2 was equal to minus 120. V3 was equal now to minus 500, and V4 was equal now to plus 500, and V4 was equal to minus 500. So we placed it now by minus 240, minus 120, 500, minus 500. This is going from negative to positive, which is a plus for V3, and this one is going from positive to negative to minus for V4. And so we can now calculate Ni4, which is a numerator value, by finding the determinant of this matrix and then put it over delta, and we get the value for I4. Let's do that. So we say Ni4 is equal to that, so it's equal now to 12 into 6, 0, 0, 0, 5 minus 4 minus 120, 500 and minus 500, plus minus 2 into minus 200, 0, 5 minus 4 and minus 240, 500 minus 5, minus 240, 500 and minus 500. And notice here we are using the algorithm of the PDM processing, but the only thing we're using, not using absolute value of the elements, we're using real values as calculated by the method shown. And also we're using full determinants by taking crisscrosses, cross multiplying and subtracting. That we didn't do in the partial determinant method. We just do the absolute value of the elements and do the algorithmic process and without regards to sign. So this is no really enhancing or calculation of the circuit analysis, but we already know to calculate exponential amount of serials via the PDM method, and we have generated exponential amount of 3x3s and 4x4s and 2x2s in the processing as well. So here we have now that, and these two will turn out to be 0, which will be plus 0 into something, and plus 0 into something, and 0 times anything will turn out to 0. So we are mainly concerned with these two. And so if we further find the determinant of that, we have now 12 times 6, 72 into 5 minus 4, 500 and minus 500, plus now 0 into something here, plus 0 into something. So in effect, this left us with this, which will be equal to 72 into minus 500 plus 2000. Now for this part here, so for this section would give us now 72 multiplied by minus 500. This section would give us now minus plus 4 into 5 minus 4, 500 minus 500, minus 2 times 0 into something, so that will be a dropout or vanish, and 0 into something, that too will vanish. So this section will give us now 4 into minus 2000 minus plus 2000. That's a minus and a minus, give you plus 2000. 2500 rather. So that will give us minus 2000. And this part here would give us now 72 times that would give us 7200 multiplied by 5, which gives us to 36,000. Let's see, 72 are 2 zeros, multiplied by 5, 500, 500, 5 2 is 10. 72 multiplied by 5. Well, we get a negative. So you add that, you multiply it by 5. So 7,200 multiplied by 5. 500, 500, 5 2 is 10, 5 7 35, 36. 36,000. So in effect, that will be equal now to minus 36,000 minus 2,000, which is equal now to minus 38,000. And therefore, I4 is equal to minus 38,000 over 1368. This too will give us a negative value, which means that I4 is going in the reverse direction. Let's calculate that. Minus 38,000 by 1368. So we'll find our calculator here. We get 38,000 divided by 1368. That's equal to 27.777777. 27.777777. 1 2 3 4 5 6 7 8 7. 1 2 3 4 5 6 7 7. I guess it will be 7 all the way, a recurring 7, so they put the last one placed there to 8. And as we stress again, in small signal analysis, these decimal amperes, 10 to the minus 12, 10 to the minus 9, 10 to the minus 6, 10 to the minus 3 would be of significance. Picoamperes, nanoamperes, microamperes, and milliamperes. But for these calculations with voltages, high voltages and amperes, we could cut it off to 3 decimal places. 27.778. And therefore I4 is negative, which means that it's going in the reverse direction. So here I've calculated I1, I2, I3, and I4, and we'll come back to do another 4x4 mesh, and with some simpler voltage and some even simpler current. And then we go to a complicated one as we extract it from our PDM processing, which is a real life situation, and try to design a circuit to match it.